Hello everyone, welcome back to more Advent of Code. We're doing 2020 day 13 here today. I noticed the map is starting to move horizontally, right? This used to be like near the center, didn't it? I think? I don't know. We seem to be taking a diversion to the east here. I can't really keep track of our travels, but anyway, here we go. Day 13, shuttle search. Your ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ships embark from that port to your vacation island. You'll need to get from the port to the nearest airport. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. At timestamp 0, every bus simultaneously departed from the seaport. After that, each bus travels to the airport, then various other locations, and finally returns to the seaport to repeat its journey forever. The time this loop takes a particular bus is also its ID number. The bus with ID 5 departs at 0, 5, 10, 15, and so on. Your notes consist of 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. I assume this will be important in part 2. So our input will look like this, and we want to know which bus's periodicity ends like closest to 939 without going over. I did read this puzzle description before I started the recording, and I spent like 30 seconds thinking about it, which is all the time you really need to understand what they're asking you for in part 1 at least. We just have a number and a list of divisors, and we're being asked to compute the number, mod each of the divisors, and choose the smallest result, and that is really it. Or no, that's not quite right, is it? Because that would tell us which bus left most recently. Right? Yeah. That's interesting. What are we being asked for then? It's got to be related to division, right? Like if we I think what we want is, after we've computed the mod of each number, we don't want the smallest result. We want to take the number itself minus the mod result, and we want the smallest of those, right? Because suppose like we had 10 and I don't know, 20. Well, those would give us the same results. That's why I assume why all of these are prime numbers. But a bus that leaves every 10 minutes would next be leaving at 9:40. So how do you exactly get that result? You take 939 mod 10 and you get 9, and then you subtract that from 10 and you get 1, and that's how many minutes till the bus leaves. And I think that holds, right? Like say we had 100, 939 mod 100 is 39. You take that and subtract it from 100, you get 61, and that is indeed how many minutes till the next one leaves. So I think I'm satisfied that that's the right idea. So if we thought part 1 was the only thing to do, we would just throw away the x's, right? But since it's not, we will need something data bus, let's say, is operating period int, which will be our period, or else x. We don't know what x means, so I'm not going to call it out of service. And our input is just going to be a list of buses. And prepare is a little bit more interesting because our two lines mean different things. So prepare equals no, our input is actually more than that, isn't it? It's an int and a list of bus, right? Which is when we can first get to a bus stop. So prepare is, we first take lines, which is fine, and then we'll say parse those lines, where parse of start, actually, parse is just a list, start schedule equals first read of start, and then map bus of schedule. No, because schedule is a list of, it's a single string. So we also then want to split on comma from this, as I recall. Oh, I've forgotten what it's called. Haskell data split string on whatever. That should tell me the answer. It is called split on. Oh, data list split, right. And I have to put that into my cabal file, I assume. No, okay, let's just kill this process, I guess. Oh, I didn't mean to kill the associated buffers, oh well. Alright, forget it, I'm just quitting Emacs. I found, like, you have to say stack build, and then, like, it just... Oh, day 13. Okay, but yeah, that's fine though. It built my project, but of course it couldn't build my source file, so we should have data list split now. Yeah, okay. Why are you mad about parse, by the way? Shouldn't this lines parse? There we go. Now that's correct. And bus of x equals x, bus of n equal read n. What are you still mad about split on? Did I get that wrong? How does split on work? Cabal install split, data list split, split on. Yeah, that looks fine. Okay. So a schedule is a string. Oh, I told it bus takes a character. Right. And of course I can't just call read, I would say operating a read-in. There you go. And it's a non-exhaustive pattern, but who cares, right? So part one of start buses equals minimum map next time start of buses, where next time, actually I can just, next time has start in scope already, so bus B, let's say, I don't know, bus is fine, it's not a global, it's just this here. Next time a bus equals start mod bus, but actually it's bus minus this, right? And we need to add start to that, right? What's it asking me? It's asking the number of minutes you'll need to wait. Not, okay, so we actually don't need to add start. So we just need this, right? Data list minimum. Oh, right, next time. Oh, yes. So instead, I should just write this as a list comprehension so I can use pattern matching to easily discard the stuff I don't care about. Minimum of next time bus for operating bus from buses. All right, that looks pretty good to me. So this, when you do a list comprehension, any pattern matches that fail don't like break the program. They instead just make that iteration of the list comprehension abort. Same thing in actually, I don't know, there have been some rumblings about changes to how monad pattern matching works because fail was considered to be a mistake, so I don't know, maybe they're doing something else there, but here anyway, you can just say I only want to look at the operating ones and the x's get thrown away. So let's see how that turned out. Six. Oh, I forgot. We're supposed to the earliest the number. Sorry, here you go. The number of minutes you have to wait times the ID of that bus. Yeah, so like 6 is too low. There's no way they would give me that number. Okay. And we just need minimum by here. So what I'm doing... Oh, minimum by... It takes a function... So we actually need also import data ord comparing. Okay. So what I've done is two things here. First, I added into the list comprehension the bus that we're returning. And then I said, well, okay, great, but we only want to do minimum by the second element on this. I don't want first, do I? I want uncurry of times. There you go. Multiply them together. I guess you're right, I don't need parentheses there. So, and then minimum by says, okay, I'll I'll find you the smallest element in this list, but I won't just compare them directly to each other. I'll use this function you give me. Many languages have something like this. But it doesn't just take a way. It takes a function for comparing two values, and second isn't a function for comparing two values. It's a function for like projecting from those two values to a smaller set, i.e., they're only their second halves, or from a single value to its smaller half. And so comparing, if you look at the type signature here, just takes a function from b to a and returns a way to compare things based on that function. That takes two b's and returns an ordering. So that was what that was all about. 4,938. That seems possible, I assume. I mean, let's look real quick at the input. I have no idea whether it's right. Sure. Wait a minute. Oh, right, because we're multiplying by the bus. Yeah, so it's like most of these are much smaller than that number. How could we have to wait that long? Answer, we don't. We're reporting how long we wait times the bus. So if we factored this, we could find out what the parts were. Okay, that's the right answer. Great. Let's see what part 2 is all about. The shuttle company is running a contest. 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID such that the first bus ID departs at that time and each subsequent bus ID departs at that subsequent minute. What the fuck? I can't parse this sentence at all. Anyone that can find the earliest timestamp such that okay, the first bus ID departs at that time, and each subsequent listed bus ID departs at that subsequent minute. So we're looking for a timestamp. And at that timestamp, it should be exactly equal to the first one. It should be exactly equal to 0 mod the first one. And each subsequent bus ID departs at that subsequent minute? X in the schedule means there's no constraints on what bus IDs must depart at that time. I see. So this should be equal to 1 mod 0 mod 7, 1 mod 3, 2, 3. Sorry. 0 mod 7, 1 mod 13. Doesn't matter about 2, 3, 4 mod 59, and so on. We have to find such a number. This really reminds me of an Advent of Code problem from years ago. When was it? It can't have been 2015 because I remember I was living somewhere else when that happened. Well, in a different city. I think it was 2016, because I think that was the year I did Python instead of Haskell, right? I'm going to do a little bit of searching here. I remember that was the one where I asked my sister, who's got a PhD in math, to help me, like, talk to me about moduli, because there's clearly an efficient way, and the inefficient way doesn't work. So let's just look at my repositories. I'll be with you in a minute. I guess this is one thing we might want to know, but I guess the other would be, which dang puzzle is it? I guess I could just search this for like mod problem. Oh no, in Python it's %, which like does a million things. Oh, here it is. Day 15. Chinese. I knew there was a Chinese remainder theorem thing going on here. I was like, isn't this related to the Chinese remainder theorem? I said to my sister, and I forget. She must. I hope she said yes. It looks that way, right? So what was going on in 2016, day 15? What was that puzzle about? It was about like dropping marbles through a thing, right? Kinetic sculpture, yeah. Discs are spaced out so that after you push the button, 1 second elapses before the first disc is released. 1 second elapses, and as it passes to the one below it. So it gave us this thing saying, okay, we had this was more constrained because, well, not really. It gave us a set of constraints that were all like, look for a number that is equal to n mod m. And we had several of those. And okay, so what did I do? I don't remember how the Chinese remainder theorem works, but it's like a thing I remember about, like, I don't know, modular some things. So what did I do? Combine. Well, this is like nothing to it, right? What the hell does this mean? I'm computing residues, mod a prime. That's exciting. Okay, so here I'm parsing the input, and size is how, what the periodicity of it is, and then I take the int, which is, yeah, okay, this is fine. I can implement this. So all I did is sort them. I sorted them largest first because why? I guess because the only way to do it is to try. Right, because we're basically asking you to do mod to do division modulo a prime, or like compute the remainder mod a prime, which is not something we know how to do efficiently. But we do know that you can do it in time linear with like the size of the prime by just guessing everything. And if you do this, you will leave alone. Oh, right, because this is, we're building up a really large. What do I leave? So I'm combining. I first say, okay, it must be equal to n mod p, and then here's another constraint. It must be equal to q mod m. Or m mod q, I'm sorry. And so the idea is I figure out some way to achieve this mod without disturbing this one by only iterating in groups of p. And then I say, okay, now I have new constraints, which are, it must be equal to x mod of p times q. All right, this makes sense now. Now I understand what's going on here. So and the reason to do the largest ones first? X mod q. I'm not sure why it matters that I do the largest ones first. It looks like it would be fine, right? To do it in any order. For each new prime, we're doing work linear in the size of that prime. Yeah, we could do this in any order. I don't think it mattered that I sorted it. I thought it might. I guess I thought it would be more efficient because like figuring out the largest wheel without having the constraints of any smaller wheels might be nice, and then once you've done that, you can do the smaller ones more easily. But I think it actually doesn't matter at all. I'll try it once and then see if it makes any difference after sorting, but I don't think it will. All right. Well, we definitely will not need lambda do or applicative do or lambda case today. So what we have to do, I guess, is write data constraint is what we'll be folding over. So constraint is a constraint of residue and prime, which are both ints. Seems easy enough. And our part one is going to be I guess fold L1 of what is it we're trying to residue fold L1 of combine on parse map parse constraint second, and then we just have a couple functions to write here. Parse constraint of hang on, I can't just map because I have to keep track of which keep track of the offsets, right? So map is the wrong function. Are we looking for a scan here? Let's say cat maybes scan L This does not seem right. Because what's the difference between like scan L and map a cum or something? If we look up scan L, so it takes a, it just like it's the same as fold L, except it gives you a list of the intermediate results. But I think what I want is map a cum L, which takes, yes. Oh my god, this type's a little general, but we could look at the one in old list and it's a little simpler, right? It takes an accumulator and an item, or function from accumulator and item to new accumulator and output. And then it takes the initial accumulator and a list of items, and it gives you the final accumulator and the list of items. So it kind of does the job of like, you could build it, oops. You could build it yourself with, I thought it would take me back to the previous search result, but I guess I never hit enter, so okay. You could build map_accum_l yourself out of scan_l, but it's not really as convenient. We want map_accum_l to accumulate our to keep track of what int we're on, right? So we say map_accum_l, taking an initial input of, say, 0, I think. Parse constraint 0. Is that right? So map_accum_l is in what? Oh, it's in, I don't know, maybe it's in data list. It looks like it's in data list. It's also in data traversable, so it might just automatically be in scope. Oh, this looks like the old one. It knows about lists. I don't know, whatever. Parse constraint. We need it to take the accumulator first, which is offset. And then it takes a bus equals, right? The new offset is just the next offset. And then the bus is, let me read the problem statement again. Are there specific offsets from T? Okay. First bus ID departs at that time. The earliest timestamp, and we're ignoring the timestamp we were given, 0 would be fine, departs at exactly that time. So we want it to be equal to 0 mod the first bus, right? And then 1 mod the second, and 2 mod the third, and so on. Okay. We should be careful. Case bus of x. We need to return, well, actually, we're returning the next offset regardless, but in the set of constraints, there may be no constraint if there was nothing. Otherwise, operating just operating of okay, so we need map_accum_l from data list, fine. We need cat maybes from data maybe? Yes. And now we need to implement combine. And that's the thing I wrote in Python last 4 years ago, I guess. So combine takes 2 constraint objects. Constraint of and we take the residue first. Wait a minute. I need to build a constraint here. Constraint. Now's my chance to change the order of this. I think I want it to be residue and then prime, so you can say n mod p, which kind of rolls off the old tongue there. So constraint is just offset, like oops, there you go, like so, right? Constraint of n and p and constraint of m and q equals. Now, what was this dang algorithm I wrote in Python here? It seems, I mean, it's simple. I don't think I should rewrite, I don't think I should implement like this in Haskell because it's kind of, I mean, obviously you could do it with like a fold, but it seems nicer to do as like a sequence operation or a list operation. What we want is, I mean, it's, now that I understand like what the point of this algorithm is, I don't think I need to look at it, so I don't know why I did. I want the, well, it's definitely a constraint of x, let's say, and p times q, where x is equal to the first item which meets the condition that it is equal to 0 mod I can just look at q, right? Yeah. Iterate plus p starting at where do I start exactly? Not equal to 0, equal to our new constraint, which is m, and we're starting at n. Right? Yeah, because we're preserving the property that our number is equal to n mod p by starting with n and increasing by p each time. And then we're adding this new property that should be equal to m mod q. That seems fine. Okay. So what's it mad about? MapQML's type doesn't match, and residue's type doesn't match. So let's give these guys types, shall we? Well, combine clearly has the type constraint to constraint to constraint. That's very clear. I wish I had a better editor integration so that I could ask like, hey, what is the type of this, right? I mean, I guess this is an interesting point that doesn't really matter, but my bus type is just like maybe int, and I could use some better tools if I had represented it as maybe int. For example, this is just like an fmap implemented badly because I'm transforming from my type to a normal type. But I think it was fine. So what's the type of, like, I don't know. Let's just make sure that the types are actually right. Yes, that's fine. Parse constraint is a function from int Oh, did I look at the order? Did I give it its type in its arguments in the wrong order? I don't think I did. MapQML takes an accumulator and then the next input. Yeah, that's fine. So it takes an int and a bus and produces a pair of int and maybe constraint, I think, right? Yeah, so it inferred all those types correctly. I just combined them wrong. Oh, the problem is I forgot to split, I forgot that my input contains junk I don't care about, the initial int. So, okay, that was that. Now what's wrong here? Ah, of course. I also don't care about the final accumulator returned to be my map.qml, so I can just say this. All right, let's give it a try. Stack run. Should take a little while, but we're only doing linear work for each prime. And it should fit in 64 bits because, I don't know, Eric doesn't expect people to have access to a big int library. We do. This makes me nervous. Okay, well, let's then define like a test.text that's the test input they give us. Where is it? Here's one. Sorry, you guys can't see it, but it doesn't matter. I'm just grabbing it from 1713. So it's this. Hello? Okay. So if I said test.text, is it gonna like run at all? It does. It produces a number, but it's the wrong one. It's much too large. We were looking for, well, it's not much too large. We were looking for 1 million, and we got 2 million? Okay. So the listed bus IDs at their specific offsets from T. Those bus IDs can depart at other times, and other bus IDs can depart at those times. The only requirement on the first minute here is that bus ID 19 so we have 713 and then 2 X's and 59. This all makes sense. Okay. So maybe what I will do then is let's derive a show here and just say that it's equal to this, so I can see what are the constraints that I have parsed from this, and are they the ones I expected? Is the problem in that, or is it in my... This looks right. It should be equal to 0 mod 7, 1 mod 13, 4 mod 59. Yeah. Okay. So the problem is with my math somewhere. Well, first of all, let's go, like, no. Let's go look at the math again. And our constraints are n and q, residue and prime, n and, right, so we say constraint, we get this new x. Oh, I forgot to do... I see, I made it more difficult for myself. I forgot to reduce the results mod p times q each time I iterate, didn't I? I think that's something I should probably do. I didn't do that in the Python version. There might be a reason. But oh, maybe that's why I did it in sorted order, so that I wouldn't have to do the modular reducing. That actually kind of makes sense now that I think of it, but I don't know if it's true. I think I could also... Right, the idea is, if you've already solved the biggest single wheel, I don't know. If you solved the biggest single wheel and you got something that's like... the problem, I think, is that in the last one... Well, no. I was thinking that we want it to be equal to 0 mod a bunch of things, but that's not true. We want it to be equal to 0 mod one thing, 1 mod the second, and so on, right? But like, it seems obvious to me that there should be some modular reduction happening here. I think somehow, like, take the result mod p times q. Does that make sense at all? Will that ever do anything? Like, suppose the p and q were 5 and 7. And I said, okay, I need something that's equal to 6 mod 7 and equal to 1 mod 5. Let's say the larger one, the new one was the smaller one. So I already know that it needs to be equal to 6 mod 7, and I need to preserve the property that it's equal to 1 mod 5. I would start at six and increase by 7. And oh no, I don't want to reduce mod anything, because what would happen is if I reduced, well, if I reduced mod 35, it would be fine. No, I don't. I mean, I guess it would, but it would also never do anything, because I'll never I'll never need to go through all iterations. Like, p times q is the largest a number could possibly be. p times q minus 1, really. The largest it could possibly be to meet all these constraints. So taking it p mod q will never do anything. All right, let's try a really simple. First of all, let's just lift these out, I guess. Or, well, I can leave parse constraints in, I guess. And then just play with this in the REPL. So, whoops, REPL's over here. Combine constraint of, well, we'll do the ones I said, is equal to 6 mod 7 and 1 mod 5. We should just get, like, 6, right? Oh, whoops. Yeah, and then it says it should be equal to 6 mod 35. That makes sense. But instead I said, oh, it needs to, I forgot, it needs to be, 3 mod 5. I mean, that looks right. 2? Needs to be 27, so that's equal to 2 mod 5, right? Yeah, and it's still, so this looks right. And if I did it in the opposite order, would it still work? Yeah. All of these seem fine. How did I even come up with 6 in this case? Okay, wait a minute. Maybe I just like... Well, it can't be that I forgot... Surely the actual earliest will be larger than... So how many digits are they giving me here? Maybe it does need to be a big int. Well, no, because we failed on the test input, so... So what if we said part 2 of prepare... One of the other examples they give us, 67, well, x, or 1, we don't care about the first thing. 67, 7, 59, 61. Oh, of course, I needed to put back part 2. What? Oh, I deleted that instead of just deleting the comment. Got it. That's way too large again. Well, let's just test it by hand then. 933, 913, mod 67, hopefully 0? Oh, that's not how you do mod. I was looking at Python too recently. That's 0, all right. And mod 7, we hope this should be 1. It is. Mod 59 is 2. Okay, so I'm getting the idea here that that's 3. That I've implemented the right algorithm. Or I've correctly implemented the algorithm that I thought would solve the problem, but it doesn't solve the problem. Actually, what is max bound int? How many digits is that? Well, I can length show max bound int. Actually, can I just write @int? Do I have that version? Okay, I could, but 19 digits. So we have plenty of room to work with. They tell us to be careful. We can deal with 15-digit numbers. Okay, so ints are fine. And let's also, just while we're here, confirm another one of their test inputs that has an X in it. There we go. Oh, that's a much smaller number. It's actually too small. Huh. So what's 772 mod 17? It's 0. Fine, I'll put an int in so you can stop warning me, jeez. And mod 13? It's 2, as we wanted. And 3, not 3, 19. Hopefully it's 3? Yeah. But it tells me the answer here should be 3,417, even though I've validated that this exactly handles, like, according to my understanding of the problem, these are all correct, and they come before what the right answer is. So clearly my understanding of the problem is incorrect. Let's read it more carefully. We're clearly trying to set up some set of constraints on different moduli, but I just have the wrong ones. Bus 7 wait a minute. You're looking at bus ID 7 departs at timestamp t. Bus ID 7 departs at 7 minutes after t. Does anyone care about that? They're just saying nobody does care about that. It's fine that it also departs here, because the one that counts is here. That's fine. So we do want that it should be equal to 0 mod the first bus. Oh, I think I'm doing my subtractions backwards, kind of. We don't want. We're looking for this timestamp, and we want the next bus, I think, to be at -1, not 1. Is that right? Because this bus is 0 at this time, which means at this time it shouldn't be 1, it should be -1, or rather, the bus's periodicity -1. Okay, and I think -1 actually would work. So we can just make a very small change to our parse constraint function. It's not constraint offset period, but it's period minus offset and period. What are you mad about here? Oh, I broke. Yeah, there we go. I was like, I couldn't figure out where the end parent that was dangling here had come from. I forgot it came from here. Okay, so if we now try part 2 of this, we get 3417, and that, I believe, is what we wanted. Yes, very good. Now if we go back and look at the other one, the longer one we tried. Oh, is that the same one? No, here we go, this one. 754018, and that's what it was supposed to be. Okay. Cool, so let's try running this now. Now I'm a little concerned it might be too large, too slow. No, okay, the reason it was slow before is because we were searching for the wrong number. Got it. It's not the right answer, it's too low. Too low, huh? Looked right to me. Hang on. Did I leave my input pointing at the test file? Yes, okay. No wonder it was so fast. And I think this is like the fastest way you can do it in principle, like, right? I must be missing something, because I know Eric makes it so that even on bad hardware, the right algorithm can run in a reasonable amount of time. And I have like okay hardware. It's not amazing. It was pretty good a few years ago. I don't really play any intensive games, so I don't update it. Like, I think I actually haven't updated this one ever. I did update my old one a few times. But like, what are we supposed to do that would be more efficient than this? Because we have like, I mean, let's go look at our input here. I don't even understand why it's taking this long, because we only have 1, 2, 3, 4, 5, 6, 7, 8 inputs, right? There's only 8 constraints. And for each constraint, the amount of work we're doing is very small. It's just linear in the number of constraints. We should be doing like a couple thousand additions or something? Something's wrong. You know what? Maybe it actually does exceed the integer size. Let's just in case, let's just use we'll use an integer here. And this should fail, right? Because I need to, oh, my constraints need to have integers as well, right? And I just need to have parse this needs an integer, this needs an integer. And all we have to do is take our bus is period here. Where p equals from integral period. To integral? I don't know, I always forget how numbers work in Haskell. Oh, I can ask the REPL, right? Num? From integer, okay. Integral? To integer, okay. What do you mean it's not in scope? Oh! There you go. That's why it wouldn't indent right. The parenthesis closing this tuple was messing it up. Okay, so let's just run it again. Because like, you would expect it to maybe run for a very long time if it ran into integer overflow or something, right? because like then it might never find the right answer. This is very puzzling. I'm sure we're doing a very small amount of work. Oh, you know what? Maybe this is why it was important to sort, because... Well, no, hang on. Huh. So I'm adding P. And I'm definitely doing this at most Q times, because my stopping point is that it's equal to M mod Q. And since Q is a prime, I assume, that would be something important to check, wouldn't it? What if it weren't a prime? Then this whole thing would fall apart, I think. So we could check that real quick. B where B equals how do you Haskell is prime? Like it's got to be built in somewhere, right? I think it's not though. It's like ugh. Yeah, you have to write it yourself. I mean, we can do it. It's not that hard. We don't care about doing it efficiently because we have a very, very small set of inputs. If prime B equal error of show B, and we'll just write real quickly here prime n equals null 0 up to n m for m coming from this range where m mod n mod m, I'll start with 2 I guess, and go to n minus 1 equals 0. So this is like the worst performing prime number tester you've ever seen. There's already an existing binding? Where? Oh, in constraint. I don't care about that. So this is still running. It's clearly like not a great idea to wait for it to finish. So if I say stack run, do I get any errors at the beginning? No, it looks good. So that's not the problem. get rid of this. So we're given primes. This is so weird. Where is the work going? What's it spending time on? Like if I said, prepare, say, of like 2, 3, 5, 7, 11, 13, 17, 19. Like this should be insanely fast, right? Yeah. Did I remember to actually, I did the constraint here. P minus offset. So we take the period. Wait a minute, wait a minute, wait a minute, wait a minute. Oh no, I see what's wrong. When we made this change to subtract the offset, we broke the 0 case, the first bus. We're looking for something that's equal to P mod P, but we stop if we get, like, that never happens. P mod P is 0, not P. This would be correct, like, mathematically, but since I'm saying compute the remainder and then check that it's equal to P, rather than saying is it equivalent to P mod P or whatever. So this is the problem. Because if we didn't have a first bus, this would work by luck, but still be wrong. So I think we could actually put this all back to ints probably, but let's leave it at integers for now. And we'll just say R here. And we'll define R. R equals mod. Am I crazy? This is dumb, right? I don't want any mods. I could take it mod P, but that's basically just saying like it's just basically this. Like this basically is the idea. Residue prime. Yeah, so we could say P minus offset mod P, and all that does is like let us write this in a more convenient way. Hey, you're guaranteed to be fast. Don't you give me this shit. Okay. So I think we're still parsing wrong somehow. But wait a minute. If that was the problem, why did our tests all work on the sample inputs, right? Like this. Did I just get lucky? Somehow? Like, this is all fine. This takes a bunch of time for completely inexplicable reasons. How many of these can you handle? Oh, well, of course this will never succeed. Because we're looking for something... now we're looking for something equal to 0 mod 2, 1 mod... Well, we don't care about this. What? It's equal to 1 mod something, 2 mod something, 3 mod something, 4 mod something, 5 mod 3. And that will never succeed. Again. Okay. So now that makes sense. We have to... We actually do want to take the mod. We want to do this whole thing... We want to do a mod here because... the offset might be larger than the prime. So... Or the period, or no, I'm a little lost now. So if we said, like, let me just, Haskell actually does mod, like, it has remainder, but it also has mod. So like, and the difference is for negative numbers, like -1, remainder 8 or whatever, you get like -1, which is not usually what people want when they want mods. What? I thought mod behaved differently here. Does it only behave differently with negative remainders? Okay, that's weird. I don't understand. So we have a constraint, but we have to be careful how we define it. Which is, we have an offset, and we don't need like this anymore, I think. We want p minus offset. P is the period, which is our prime. Helpfully, those are both p words. We want it to be equal to p minus offset mod p. So I think we can just say but it's not actually, because as we discovered, like if p were, let's say let p equal minus, or p is 3, offset is 8 in p minus offset mod p, we get 1 actually. Maybe this is right? What was I doing before that was wrong? -1 mod 8. What I don't understand is why that gave me a negative number. Maybe it's because I used integer instead of int? No. I mean, okay, we can test this while we think. We got an answer instantly. Okay, so that's what I thought should happen, but I don't understand why subtracting and then going mod the thing. Like, why did I get a negative number here, but I never got any negative numbers in my actual program? Really weird. Anyway. Let's enter this gigantic number. That's the right answer. Okay, cool. So let's roll back this change about using integers. And we'll just replace p with period in all of these cases. Actually, we'll just replace this with p. There you go. Why is this upset? Oh, because I don't understand. I got rid of the trailing parentheses again. That's what I get for trying to, I don't know, it's like, working in other languages, you kind of get used to control flow being separate from the expression language, right? If you want to do an if, you have to make it a statement, and then you do some operations. But like in Haskell, and for example, like every Lisp in the universe, everything's an expression, including control flow statements, and you can just, if what you want, like, you don't have to say if foo, then, you know, f of x, else g of x. You know, and in a, if it's that simple, even in modern languages, you can say, like, you can use a ternary to compute either f or g and apply the result to x. But it's really, like, not so easy to compute an entire function like in that style. Here, it's really nice to be able to just embed logic inside of control flow where it makes sense. I know I'm going to pair this with like the successor of offset, and it would be kind of dumb to have to write case bus of x, successor of offset nothing, operating p, successor of offset just foo. And so I like to write in this style when it makes sense. But I sure am thrown off by this trailing parenthesis every time. So what did we end up doing? Looks fine. Git add p. Let's just let's throw that out there. Day 13, part 2. Four? I think that's far back enough. We only made 3 commits, right? We'll just put that in fix up. So that we never committed all this see, we never committed lambda case or applicative do because we didn't need it. I could have considered reverting out the prime testing thing at the end. But I think it is actually kind of important to have that constraint in there, because if we ever use a non-prime number, I'm not at all sure that our... Yeah, I'm in fact quite sure that our algorithm would be incorrect. It would... Well, I'm not sure, I guess. I think you would have to compute the least greatest common divisor before you do the combine thing or something. Anyway, that's all for today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.